Morning, everybody, and welcome to my presentation. My name is Bungab Abdelhamid. I am a PhD student at the University of Ouargla. The topic of my presentation is the optical modeling analysis of glass tin oxide thin films. I've divided my presentation into three main parts. First of all, introduction. Second, I will talk about experimental details and result discussion. Finally, conclusion. Introduction. Today, the debate is focused on the choice of the PN and P-type semiconductor transparent conducting oxide in thin film for PN junction. PN junction is used for many optoelectronic devices to develop low cost and more efficient, but tin oxide is candidated for PN heterojunction. Tin oxide film have wide range of applications such as component PN junction diode, electrochromic material in smart windows, active material in chemical sensor, photocathode in the synthesized solar cell, and anode interfacial layer in polymer solar cell, and random access memory devices. The deposition tin oxide film can be obtained by different methods including chemical deposition, sputtering, electron beam evaporation, atomic layer deposition, bleached laser deposition, chemical sol gel, spray deposition, and others. Using economical method of ultrasonic spray pyrolysis and sample solution, not rare earth. The properties of tin oxide thin film has been studied using XRD, use EVVs near the spectroscopy ellipsometry and others. Spectroscopy ellipsometry. Why on alpha spectroscopy ellipsometry? It's easy to use, powerful, flexible, affordable, and fast. The light interaction with the thin film and substrate in figure optical of properties will vary with wavelength and are often referred to as optical function. For most materials, the optical function are described by two values at each wavelength, the index of refraction N and the extinction coefficient K. The index describes the phase velocity and is used to determine the refraction of light entering a transparent film. The extinction coefficient describes the absorption of light as it travels through a material. The overall interaction between light and the sample layer and the substrate produce the polarization change measurement by ellipsometry. Experimental detail. Preparation of pure tin oxide was prepared by dissolving 0.1 mole concentration of the precursor tin chloride dihydrate in half ratio with ultra pure water and methanol for 50 milliliter volume of the solution. Deposition and characterization. Spray pyrolysis technique equipment consists of precursor solution, an atomizer ultrasonic, substrate heat source, and temperature controller. The equipment used in this work is hallmark. Depot parameters. The prepared chemical solution was deposited on the substrate heated to temperature of 400 degrees. Was carried out using an ultrasonic atomizer. 5 minutes with balayage on both X and Y axis. Speed 205 in both X and Y axis. The solution deposition rate was 2 milliliter per minute and the spray nozzle at height 8 cm. Characterization equipment: X-ray diffraction measurement, EVV spectroscopy measurement, spectroscopy ellipsometry measurement. Result and discussion. Tin oxide structure properties. Chow in figure represent the XRD patterns of spray deposited pure tin oxide thin film. Chow the dominant peak at 2 theta 51.58 and less intense peak were recorded at 37.79 and 33.53, which correspond to 211 200 and 101 crystal plane respectively, and other less intense peak observed XRT patterns are in good agreement with ACDD card number 41 1445 of tin oxide film, are polycrystalline with tetragonal structure. The average crystalline size of tin film is calculated using formula varied for 12.61 to 81.27 nanometer. Plot of energy tin film represent the optical band gap energy to tin oxide tin film calculated using absorbance data is equal to 3.95 electron volt. For transmission spectra of tin oxide tin film is equal 90% invisible light. Spectroscopy ellipsometry characterization, the delta variation versus wavelength and the psi variation versus wavelength of tin oxide tin film. In this figure also highlight a key feature of ellipsometry measurement are performed at oblique angle, but the wavelength and angle of incidence can be varied to produce polarity of measurement data, often referred at 70 degrees angle spectroscopy ellipsometry measurement. The extension coefficient variation versus wavelength of tin oxide tin film and the refraction index, the result show the extension coefficient equal to 0.11 at 632.8 nanometer at 70 degrees, and refractive index is equal 1.84 at 32.8 nanometer at 70 degrees. The thickness of tin film tin oxide using B-spline model for tin oxide and Cauchy for glass. The modeling of tin oxide and glass tin film could be modeled by Cauchy dispersion, and B-spline model is used for determining ideal thickness and optical constant. The various structure used ideal with roughness graded and with roughness graded. Thickness equal to 188.52 at 632.8 nanometer. Conclusion: the tin oxide tin film were deposition using the simple and low-cost spray pyrolysis technique. Parameter: the cleaned substrate ultrasonic, the nozzle ultrasonic, and the temperature substrate where the tin oxide decomposed. The preferred orientation is 101, 211, and other that confirmed tin oxide films had tetragonal structure. Optical study shows better transparency tin film at 400 degrees and large wide gap at 3.9 electron volt. Spectroscopy ellipsometry study at 70 degrees obtained the variation in the optical constant and allowed obtaining the film thickness. All studies in this work confirmed the tin oxide tin film are semiconducting in nature, and spectroscopy ellipsometry is the best method for obtaining the real optical constant for transparency tin film on glass substrate. Tin oxide tin film are good candidates for PN heterojunction to be used in optoelectronic device. Thank you for your attention.